Question 1, you need to rewrite sec x as 1 over cos x and then differentiate that to show that you get sec x tan x. So there's a few different things that you can do. This is a fraction, so you can use the quotient rule. So you can say u is the top of the fraction, v is the bottom of the fraction. If you're using the quotient rule, just be careful when you differentiate u. So lots of you put when you differentiate this, you just get 1. But actually, when you differentiate 1, you just get 0. So then you would differentiate v, which you should know what that is. And then you would just do v times this minus u times dv by dx. And then you divide that all by v squared. You want to show that you get this. So just a reminder, sec is 1 over cos. And tan is sine over cos. So you will need to look at your answer for this, for your dy by dx, and just show how you get this, and therefore it would be equal to that. The other thing that you can do here is you could say that actually that is cos x to the minus 1. And then that would be the chain rule because it's a function inside of a function. So what you'd have to do is bring the minus 1 down, make it 1 less up here. So it would be minus 1 cos x to the minus 2. And then just remember to times that by what you get when you differentiate cos. That is the bit some of you are forgetting to do. So it is like normal differentiation, but you times by what you get when you differentiate the bracket. And again, you then need to show that you can get this and therefore it equals sec x tan x. So for part B, you've got two different functions here that are times together. So this would be the product rule. So you should be saying that u is e to the 2x. V is sec 3x. So you need to differentiate both of those. And then product rule is just where you times them together like that. On question 2, it's a trig equation, but the trouble is that you've got cosec and you've got cot. So you are unable to solve it while you've got two different trig identities, not identities, functions, sorry. So you need to make sure that you have got this all in terms of the same trig function. So if it's to do with cosec and cot, we know that cot squared x plus 1 equals cosec squared x. So you want to get rid of either the cosec or the cot. It's going to be the one where it's squared because they're all squared in the identity up here. So we know that cosec squared is actually equal to cot squared x plus 1. You just got to be careful because it is 2x, it's not x. So it will just be cot squared 2x plus 1, and then you've got this minus cot 2x equals 1. So you can simplify that by taking away 1. So if you take away 1, you're going to get cot squared 2x minus cot 2x equals 0. This you can factorise, so you can take out a cot 2x and then you're going to get cot 2x minus 1. So there are two solutions to this. Now the first one we haven't really done in class yet. I didn't realise this came up in the homework. However, it's quite simple to quickly say now. So it could be that cot 2x equals 0. Or it could be that cot 2x equals 1. So I'll start with the one that we haven't really quite talked about yet in class. So this one would be the same thing as 1 over tan 2x equals 0 because cot is 1 over tan. To solve something like this, normally you would times by the bottom of the fraction. If you times by tan 2x though, it's going to times by the 0 and it basically just disappears. And it looks like basically it doesn't really work. So you need to think about where this would equal 0, and that is where this is basically a really big number. So thinking about your tan graph, which looks like that. As it approaches 90 degrees, this is now starting to head up to infinity, isn't it? So as that gets bigger and bigger and bigger, this whole fraction is therefore going to get smaller, because if this is getting so big, 1 over something that's like really, really big is basically going to be equal to 0. So for this one, you would say that 2x is going to be 90. Because it's dealing with 2x, we should have doubled the range here, so it's going to be 360. And tan repeats every 180 degrees. So therefore, if you add 180 to 90, you're going to get 270. So the other solution for this one is 270, and then you would have them both. This one we have done lots of in class, so this one, just to start you off, you're going to get 1 over 2x equals 1. So if you times by tan 2x on this one, you're going to get that tan 2x equals 1. So that is where you would do your tan to the minus 1. You need to use the doubled range still, so the 0 to 360. Tan to the minus 1 of 1. Find your other solutions. Tan, you need to add multiples of 180. And then just remember to have all your answers as well. Question 3. So same kind of idea really, especially when you get onto this one here. Part A is exactly like we've done before in lessons. So we're trying to show that it equals this. There's a tan squared in there. And I know that I get tan squared when I do sine divided by cos. So you need to just go through and divide every term by cos squared. And then basically you're just going to get what you have got there. That's why it's only 2 marks. And then for the equation, again, you can see you've got 2 trig functions in there. So you've got sec and you've got tan. So you will not be able to solve it while you've got both of those in there. You need to get it all in terms of one trig function. So if it's to do with sec and tan, we know that 1 plus tan squared theta equals sec squared theta. So these are in terms of sec. It would make sense to get rid of this. If you got rid of the sec squared, you would still end up with a sec here and everything else would be tan, but you would still have 2 trig functions. So you need to rearrange this one to get tan squared and substitute it into here. So it would be 2 lots of sec squared theta minus 1 and then plus 4 sec theta plus sec squared theta equals 2. So you would need to, from here, expand your brackets, simplify it. So you're going to get 2 sec squared here plus this one. So you're going to get a 3 sec squared theta. Then, because it's going to be a quadratic equation, you want to make that equal 0. And then I would try and factorise it. Obviously, if you cannot factorise it, you would have to use the quadratic formula. And then you would do the usual thing of replacing sec with 1 over cos, rearranging it to get it to be cos theta equals something, and then do cos to the minus 1 and use your CAS diagram and so on. Question 4. What I just want to point out with this is when it's saying find the equation of the normal, some of you are working out the gradient and then stopping there. So just make sure that you are actually finding the equation. So you do need the gradient, but you also need the point that it goes through. And then you need to put this into y minus y1. You don't just stop when you've got the gradient. So first thing that you're going to have to do is you either find the point or you find the gradient. So if we go for the point, so we know the x coordinate is 2. So you just need to substitute 2 into your equation here to get your y value. So that's going to be the coordinate. Then we need to get the gradient. So again, you could use quotient rule here because it's a fraction. So you could say u is 3, v is 5 minus 3x squared. So to differentiate this one, it would just go to 0. This one, it's the chain rule inside of the quotient rule. So you would bring the 2 down, make the power 1 less, and then times it by what you get when you differentiate the bracket, which is minus 3. So it's going to be minus 6, 5 minus 3x. So quotient rule is this one times this one minus this one times this one all over v squared. Then you need to put the x coordinate, which is 2, into your answer for dy by dx. That's going to give you the gradient of the tangent, but we want the gradient of the normal. So once you've got your gradient of the tangent, you then need to make it perpendicular. Then you will have your gradient. This will be your point, and then you put it into y minus y1. Question 5 is just solving equations with lens and e's in it, so like we did in year 12. Just something to point out, it doesn't actually crop up here. Before you take e's of both sides, you need to make sure you've isolated the len, which it's already, there's nothing in front of it or added to it, so it is isolated. Same with this one as well. You can't take lens of both sides until that e is on its own. In this case, it is on its own, so it's fine. So in this one, you would e both sides. When you e this side, you're just going to get 3x minus 7 because they are inverses. And on this side, you get e to the 5. It does say exact solutions, so therefore you're not looking to work this out in your calculator, just rearrange it to make x the subject. This one, you would start by learning both sides. So when you learn this side, you just get 5x plus 3. And again, rearrange that to make x the subject. Sorry, I just realised you can't see 1 minus, and there you go. So you don't need to work that out on your calculator. You are just looking to make x the subject. Question 6, factor theorem. So that is when you put minus 4 into here and show that you get 0. Factorising it, so that is where you do your long division. So you would be dividing this by x plus 4. And then you would do x plus 4 in brackets times by what you get here in brackets, and then see if that can factorise again. So quite often the bit here will simplify, or not simplify, will factorise again into another couple of brackets. Question 7 is just hypothesis testing. It should be a nice straightforward question on it really. So we know that 5% of them are found to be faulty, so that would be 0.05. Let's have a quick look. So they want to know whether it has increased. So your null hypothesis would be, up a little bit, would be that p equals 0.05. So therefore the alternative one would be, if they want to know if it's increased, it would be that p is greater than 0.05. Now it's a sample of 18. So it's binomial 18, 0.05. In that sample of 18, 4 of them were found to be faulty. So you use the same sign as this, but with a line underneath, and you'd be finding the probability that is greater than or equal to 4. So in terms of working that out, that means it could be 4, 5, 6, 7, all the way up to 18, because 18 is the number that there are. So that means that the ones you don't want are 3, 2, 1, and 0. So 0, 1, 2, 3. So what you want to do, this would be the probability that x is less than or equal to 3. Those are the ones we don't want, so you need to just take that away from 1. So you would be using the CD function on your calculator, putting in 3, because that will give you this probability, but then taking it away from 1. So the final question then is a stone throw one. There was one a bit similar to this on the last homework. I'll make sure the mechanics question next time is a little bit different. We'll do one with pulleys probably next time. So it's thrown vertically upwards with speed 16 meters per second. It's already 8 meters above the ground though. Okay, so as it goes up, it will get to a certain point and then come back down like that. So we know it hits the ground 4 seconds later, and then you've got to work out what h is. So basically what you can do is just treat the model like as a whole thing. We know the initial velocity is 16. So if we do this, resolve it upwards, so u is 16. A is going to be just freely falling with gravity, so that's going to be, it's going to be acting downwards though, so it's going to be minus 9.8. We want to know when it's hit the ground 4 seconds later, so t is 4, and then you're trying to work out s. So obviously this is to do with the displacement from here, so when you find s it will be negative, so obviously just take the negative off, but that will give you then that distance there. So your formula, if you're not sure which one to use, that is the one you need to be using, and then, oh, you can't see it, there you go. So that would be how you work out h. So the last one, and the speed of the stone as it hits the ground. So you can see all of these are not particularly great marks. They're only 3 marks each, so there's nothing particularly too much there to do. So again, we know that u is 16, a is minus 9.8, t is 4, and you're trying to work out v. So it's just sticking it into v equals u plus at.